So here we'll learn how to apply Kirchoff's laws, which we'll be learning in current electricity chapter in case of capacitors. So basically let us try to understand what are the basics. This is some circuit and this is one point A, this is one point B, and you've got batteries or cells and capacitors. Now basically one part of Kirchoff's law, which is conservation of energy, it tells us if we go from A to B along any path, the potential difference between A and B will be same. VAB we have to find out in this question, and VAB, if we go like this or we go like this or we go like that, VAB will be same. Okay, because of conservation of energy, this A is at some potential, B is at some potential. VA minus VB will not depend whether you go like this or you go like this or you go like this. Right? Like you are in the 10th floor of a building. From the 10th floor you go to the 8th floor. Whichever way you go, the change in potential energy is same. Change in potential does not depend on path. Okay, it depends only on the initial and final position. So whether we go like this or we go like this, whether you go like this, the change in potential will be same. So VAB will be same. The other thing is conservation of charge. If you look at this point B, there is no battery anywhere. Okay, so B will give charge, say Q1 to the first capacitor, Q2 to the second capacitor, okay, and Q3 to the third capacitor. So it is having no charge. So overall it cannot give any charge. Okay, therefore the sum of these charges will be 0. Because if you don't have money and you give money to 3 people, okay, from at least one person you take some money, and the total money you give out also will be 0, right? So Q1 plus Q2 plus Q3 will be 0 because here this is not having any charge. So this is giving charge minus Q1, minus Q2, minus Q3 to the split say. Now since it was not having anything, to take some charge from somewhere and then give it to others. So this is the circuit. Now we'll try to apply these two things. Now as we go from A to B, the change in potential will be same. So when we are at A, say the potential is VA. Now we go this way. We are going from minus side of the battery to the plus side of the battery. So therefore our potential is increasing by 6 volts. Right? To climb up. So going from minus to plus, therefore the potential increases by 6 volts. Now we keep on going, we come to this capacitor. Here we are going from plus to minus. This is, we have assumed it to be plus and this to be minus. So we are going from plus to minus. So we are coming down in potential. And Q is CV, so V is Q by C. We assume this charge is Q1, capacitance is 4 microfarad, charge says in microcoulomb. Therefore V will be Q1 by 4. So we are coming down in potential Q by C, that is Q1 by 4. Okay. And then we reach point B by this path. So that will give us the potential of point B. So look here. This battery, we write down the minus and plus sign carefully. Okay, for all batteries, let us write down plus and minus sign. Capacitor, we don't know which is plus, which is minus, assuming that all these sides are plus or all these sides are minus. Now we are going from A to B first along this path. So when we are here, we are at a potential of VA. Then we come to the battery, we go up in potential by 6 volts because this battery has got a potential difference of 6 volts. So we go up by 6 volts. Then we come here, we are going from the plus side to the minus side So you're coming down by potential, and that coming down by potential is Q by C. So Q here is Q1 microcoulomb and C is 4 microfarad. So we get this equation. So therefore VA minus VB will become Q1 by 4 minus 6. We can call this V. Right? VA minus VB, we can call it V. The potential difference, that is what we want to calculate. We can write it as VAB, but V is much simpler. So now we can simplify and solve for Q. This entire equation we can multiply by 4. So we'll get Q1 equal to 4V plus 24. So this is the equation we get for Q1. Now we'll do the same thing for this path and then this path. So now we start again from A. So potential is VA. We come to this battery, we go up by 12 volts. Then we come to this capacitor, we come down by charge by capacitance, which is 2 microfarad. And then we come to B, where potential is say VB. So VA minus VB becomes Q2 by 2 plus or minus rather 12, and this is say equal to V. So Q2 will become 2V plus 24. So that is Q2. Okay. Now we have got one more path to go to B. So we start from here, go up by 24 volts first because of the battery. Then we go from plus to minus side. So we come down in potential. Okay, minus Q3 by its capacitance, which is 1 microfarad. And then we reach point B. So therefore VA minus VB, which is calling it V, becomes Q1 minus 24 equal to V. So this is not Q1, this is Q3 rather. Okay, this is Q3. So therefore Q3 becomes V plus 24. So now we know Q1, we know Q2, we know Q3. Right? And we also know that from here minus Q1 has gone here, minus Q2 has gone here, and minus Q3 has gone here. Now this had nothing, so it can give nothing. Right? So the net charge Q1 plus Q2 plus Q3 will be 0. That means Q1, which is 4V plus 24, Q2, which is 2V plus 24, and Q3, which is V plus 24, will all add up to 0. So we get 7V equal to minus 72. So V becomes minus 72 by 7, which is minus 10.3 volts. That is the answer. So this is how we solve this question.